All right, this is our review for our Unit 3 test in Math 4 over logarithms. Question number 1, we're given, this should be f of x equals 5 to the x. We want to describe the transformation of the function to get this graph, g of x equals 5 to the x minus 9 plus 2. So look at what we're doing. We're subtracting 9 to the x in the original function. When you have a number that you're adding or subtracting to the x, it's going to be a horizontal shift, so it's going to go to the right or to the left. I would normally think it would go to the left because it's negative, but it's going to be the opposite of what you think. So it goes right 9 units, and then the number at the end is going to be a vertical shift, up or down, and it does exactly what I think it's going to do. It's going to go up 2 units. So right 9 units, up 2 units. Number 2, we want the y-intercept of f of x equals 5 to the x plus 7. All right, so the y-intercept means I'm going to let x be 0, and I want a point. So let x be 0, and we're going to solve for y. So replace x with 0. 5 to the 0, anything to the 0 power is 1. So that I'm going to make that 1. And then add that to 7. 1 plus 7 is 8. So that goes in here for y. Okay, if you're plotting that point 0, 8, that's where it crosses the y-axis. It's 0, 8. Y equal 8 would be a horizontal line. So that's not what we want. We want the point. Number 3, solve for x. I have log base 7 54 equals log base 7x plus log base 7 9. All right, on the left-hand side, I don't have anything to condense, so I'm just going to rewrite that. On the right-hand side, I'm adding 2 logs. The rule for adding logs is you take this argument, 9, x here and 9 here, multiply those together. Bring that log base 7 out to the front. So now you have log base 7, 9 times x. Okay, we have the same log base so that we can eliminate that and pull out our equation. 54 equals 9x. We're solving for x, so divide both sides by 9. And the 9 cancels. That's 1x equals 54 divided by 9 is 6. For number 4, this should be, there's a mistake here. This should be log base 5, 2. And in the second period, I tried to solve this without having that same log base. And I just got mixed up and probably mixed you up as well. So now that we have it written correctly, we look and we see that we have the same log base. We have addition here, so we can multiply these 2 arguments. 4 times 2 is 8. So log base 5, 8 equals log base 5x. There's really nothing to do on the right-hand side. Now I'm going to evaluate again. We have the same log base. So that's going to cross out completely. And we have the equation 8 equals x. We already have our solution here. Number 5, we're evaluating using the change of base formula. And we're going to round to the nearest thousand. So this is where I need to pull out my calculator once I have the equation or the expression set up. All right, I have log base 5, 13. Change of base formula says I can use any base, okay, in my logarithm. All right, and then I have my original expression here. This goes on the top, and the 13 goes on the top, the 5 goes on the bottom in a fraction. And I'm just going to pull out any log and any base. As long as they're the same, write them on the top and the bottom. Then you can plug this into your calculator to get an answer. I use log, the common log. You can use any log that you want. So once you put this in your calculator, you can see that I get the same answer. Okay, so this is change of base. All right, number 6 says log base 5, 2 plus log base 5, 4. Using our log rules, we're going to take the arguments 2 and 4 and multiply them together. So this becomes log base 5, when we condense it, 8. All right, it says to evaluate, so I'm going to put that in my calculator. So you can see putting it into the calculator as log base 5/8, I get approximately 1.292. And even if I don't condense it, I'm going to still get 1.292. But know how to condense this in case you're asked what this looks like in condensed form. All right, so question number 7 is a word problem. So I'm going to read through it, highlight the important information, and put it into the correct formula. In 2001, the population in Niblett, North Carolina was 950 people. If the population is increasing at a rate of 0.0 or 2%, I'm going to go ahead and change that to a decimal by bumping it to the left twice and label it R equal 0.02. Per year, as modeled by N equal N sub 0 times 1 plus R to the T. All right, this is going to be in our compounding interest formula. This is going to be A, and this is going to be P. So this is the total amount, this is the initial amount. Okay, so the initial amount that we had was 950, so I'm going to put that right here, times 1 plus the rate, 0.02, raised to the 23rd. Time is 23 because 2024 minus 2001 is 23 years. When you put that in your calculator, you'll get the answer of 1,498, and we've got to round it to the nearest person, so 1,498 people. All right, looking at question number 8, the growth of bacteria in a petri dish can be modeled by P equal 425 e to the kt, where T is the time in hours, so that's going to be in our exponent. If the petri dish contains 580 bacteria, in 6 hours, what is the value of K? So we're going to start with 580. I'm sorry, we're going to end with 580 after 6 hours. So we're going to put the 6 right here, and we're going to put the 580 here. So let me go ahead and write that out. So we end up with 580 equals, we started with 425 times E to the K times T, and time is 6, so that's going to be 6 times K. All right, now we're going to have to solve this using logarithms because we have an exponent, we have a variable in the exponent, and we're going to use the natural log because we're using E. Okay, before I do that, I'm going to divide both sides by 425. Simplify this as much as you can. Just going to keep that in parentheses, and this is going to cancel out. So let me rewrite this over here. E to the 6K is equal to 580 over 425. Let's set this equation up. So we have to take the natural, not the natural log, ln of both sides, because ln is equal to log base E. So what I'm going to be doing is, if I take the ln of both sides, I'm going to be taking log base E of E to the 6, to the 6K, and I'm trying to get that 6K out. If you have log base E and you have the same argument here as you do here, that's going to cancel out completely, and you have 6K equal, and again, we have to take the same, we took the log base E on this side. I'm just going to write it as ln on this side. It's much easier to write it this way. The calculator understands it. Okay, so we have 6K equals ln 580 over 425. Okay, and then if I divide both sides by 6, you'll have K. So let me show you what that looks like in the calculator. All right, so put all that in your calculator. Check and make sure that we have ln 580 over 425 divided by 6, and we get 0.05. Or if it asks for percent, bump this 2 places to the right, and your answer would be 5%. All right, one more word problem. John deposited $425 into an account that earned 4.5% compounded monthly. Assuming no other deposits or withdrawals are made, how much will be in his account in 12 years? And you're going to be given the formula. There's a mistake on your paper, so correct it before we start. Okay, the formulas will be on the board. Total amount equals P times 1 plus R over N, all that raised to the N times T. All right, so I've highlighted the important information. 425 is what he deposited. So we're going to start and we're going to put that right here. 425 times 1 plus R over N. N is the number of times that we're compounding in a year. So there are 12 months in a year. All right, so the interest rate is, move that decimal 2 places to the left, 0.045 divided by 12, because we divide the interest rate by the number of times we're compounding. And then all of that raised to 12 times time is 12. So 12 times 12, I went ahead and multiplied that out, is 144. So if we put that in our calculator, we'll get $728.56. For number 10, we're asked to expand this. Division with our log rules means subtraction when we split these apart. So this is going to be log base 5, 4x squared. Let me rewrite it up here. Log base 5, we take the top, 4x squared minus, again, split this apart into 2 pieces, log base 5 y cubed. Now we're still not done because we have an exponent, and we're going to pull that out to the front and write it up here. So cross that out, pull this 3 out to the front, and then we're done. This is our answer. Okay. I think I had that written down correctly up here, not here. All right, number 11, if f of x equals log 6x and g of x equals log, let me just get a new sheet of paper here, where I'll write it so we're not distracted by the work. All right, so we have 2 functions. This is number 11. F of x is equal to log 6 times x, and g of x is equal to log 13 minus x. Okay, we want to know what f of g of 4 is. All right, so we're going to work from the inside out, if you remember from Unit 1. So I'm going to let x equal 4 in function g. I'm going to replace x with 4. So we end up with log of 13 minus 4 is 9. Okay, we're going to take this and we're going to plug it in for x into function f. So all of that's going to go right here. Okay, so let me rewrite that. F of x is log of 6, put this in parentheses, times log of 9. All right, now if you're asked to take that and get an answer and approximate it, okay, you're going to take the log of 9, okay, and then you're going to multiply that by log of 6. So log of 6 times the log of 9, and maybe put this in parentheses. So those are together, and you get 0.757. All right, number 13, we're asked to write log base 381 equal 4 in exponential form. So we start with the base. So this is going to be 3 raised to the 4th power equal 81. You go back and put it in log form just to check. Log base 3, 81 equal 4. So that's what we get. Okay, for question number 14, we want to write 2 to the 4th equals 16 in log form. So you start with the word log, okay, and then we're going to write the base, what we're raising to a power right here. Log base 2. Your argument, your answer is going to be your argument right here, 16 equal, and then our exponent is always going to be on the side by itself in log form. Okay, question number 15, we're asked to factor. So we have a trinomial with a coefficient of 1. I want two numbers that multiply to give me 15, that add to give me a positive 2, that middle coefficient. So negative 15, you can break it down into negative 3 times positive 5, which does multiply to give you negative 15. And when you add negative 3 to positive 5, you get a positive 2. So we break that apart into x minus 3 times x plus 5. And this is your factored answer. If you're asked to take that and find solutions, you would go further, but you're just asked to factor. All right, B, I have a trinomial. So the first thing I look at no matter what is to see if there's something that will divide into all three terms. These are all even numbers, 2, 12, and 16, so I can divide those by 2. So factor or take out a 2, divide each of those by 2. 2 over 2 is 1, we're left with x squared. 12 divided by 2 is 6, and we also have an x on the top. And 16 divided by 2 is 8. So this is factored completely. Okay, for 16 and 17, you're going to be graphing these functions and stating the domain, the range, the horizontal asymptote, and the end behavior. So let's go ahead and put these in the calculator and take a look. Okay, let's start off by looking at f of x equals 4 to the x. All right, if x is 0, anything to the 0 power is 1. So this exponential function, the basic exponential function, is always going to have a y-intercept at 0, 1. Okay? And if I drag this point down, look at the y value. It's getting closer and closer to 0. No matter how far I go out, it's getting closer and closer to 0, but it will never be 0. All right, so our horizontal asymptote is going to be, and you can zoom in to kind of prove it to yourself, but it's going to get so close, it looks like it's part of that x-axis, but it's actually not. So our horizontal asymptote is y equals 0. Adjust the light a little bit. All right, so the horizontal asymptote for that is y equals 0. The domain, it goes from negative infinity to positive infinity. But the range goes from, the range is up and down. Again, it approaches 0. It approaches that asymptote. It will never cross it or touch it. So it goes from 0 in the vertical direction up to positive infinity. The end behavior, as x approaches infinity, y also approaches infinity because it's going up like this. So as we go in this direction, it's going up. Now we're going to look at the inverse of that function. Get that up for you. And I'm going to put in the line y equal x. So these are inverses of each other. Okay, so log base 4 of x is going to flip over that dotted line. And you can see that everything is going to reverse. So now we have a vertical asymptote at x equals 0. So it's approaching, and it gets to be undefined, means we can't divide by 0. So it's getting closer and closer to 0. Okay, but it's going up to positive infinity. So it's going to go from 0, our domain, from 0 to positive infinity, and our range is negative infinity to positive infinity. Okay, so it's really the opposite of what you had right here. Those are going to switch places. The horizontal asymptote is, instead of y equals 0, is going to be x equals 0. Okay, still the end behavior, x and y are both approaching infinity. All right, question number 18. State the domain for f of x equals log x minus 8 plus 11. All right, you can graph that. So let's go ahead and do that. So log, we're using the common log, x minus 8. Oops, where'd my x go? And then plus 11. All right, I'm going to have to zoom in though, or zoom out. Let me hit my house. Okay, so you can see that normally with an exponential function, we start at 1. That's the x-intercept. But it's going to be the y, I'm sorry, that's the y-intercept. The x-intercept is going to start at 1. But it's going to move forward, move to the right 8 units. Okay, so it's going to be approaching 8. Our asymptote is at x equals to 8. And then plus 11 is going to shift it up. So it moves up. Okay, the domain is from 8 to infinity, not including 8. Okay, so you can graph that, look at your graph to see. All right, it didn't ask for the range. Number 19, we're going to solve for x, and we have log base 6x plus log base 6x plus 2 equals log base 624. Now we're adding with the same log base, so that means multiply the arguments, x times x plus 2. You're going to distribute that x to both terms. So you have x squared plus 2x equal log base 624. These are both log base 6, so the log base 6 crosses out. So we have this equation. To solve that equation, we have a quadratic, so we're going to move everything to the left, subtract 24 from both sides, and then factor into two numbers that multiply to 24 and add to 2. And those two numbers are going to be 6 and negative 4. All right, now that it's factored, you set each factor equal to 0 and solve for x. So your solutions are negative 6 and positive 4. Okay, you always want to plug in to see if you have anything extraneous. In this case, we do not. All right, question number 20. We want to solve for x and e to the 1. Let me see if I can read that better. E to the 1.5x equals 6.42. So let me rewrite that on notebook paper. All right, this is question number 20. E to the 1.5x equals 6.42. Now we solved one earlier that had Euler's number. So we're going to use, and we had a variable in the exponent. We're solving for x. So we're going to use the natural log. We'll take the natural log of both sides, and that's going to cancel out the e. So I'm left with 1.5x equal ln 6.42. Divide both sides by 1.5, and you'll get x equal ln 6.42 over 1.5. Let's put that in our calculator and see what our answer is going to be. ln 6.42, don't put any spaces, and it will know what function you're looking for, what log function, divided by 1.5. All right, so our answer is approximately 1.2. If I bring it out to three places, 1.239, but this changes this to a 0 and this to a 4. So let's just write this the way that we see it for now, 1.2396. Let me double check to make sure I got that right. 1.2396. All right, number 21, we're asked to solve for x. Okay, we have 1.32e to the 2.1x plus 4.5 equals 6.72. Okay, so again, this is the only thing that has a variable in it. So I'm going to subtract 4.5 from both sides, minus 4.5. Okay, use your calculator. This is going to cancel out, and we'll be left with 1.32e to the 2.1x equal whatever 6.72 minus 5 is. Let me get my calculator. Yep, 6.72 minus 4.5. And that's equal to 2.22. All right, now we have something in front of that e. Let's divide both sides by 1.32. Divide by 1.32. Okay, that's going to cancel out. And so we have e to the 2.1x equals 2.22 over 1.32. So I need to take the natural log of both sides. That's going to cancel this out. We're going to have 2.1x equals ln 2.22 over 1.32. So we'll put that in our calculator and then divide by 2.1. That's going to cancel. And this will give you your answer. So let's put that in our calculator and see what we get. So practicing with the calculator is what I wanted you to do in the classroom, because this can get tricky. So watch what we're putting in and make sure that you've built this on your paper so that it's coming out the way that you think it's coming out. 2.22 divided by 1.32. Okay. And then we're going to take all of that and we're going to divide that by 2.1. So we get approximately 2.48. All right, this one we're going to expand. Okay, so we have log base 4, and we're multiplying 9 by x squared by y to the 5th. So we're going to have 3 parts to this. Log base 4, 9, plus log base 4 x squared plus log base 4 y to the 5th. Now we still have exponents here and here. So you got to pull that out in front of the log. Scratch that out. Pull that out in front of the log. Cross that out. So this would be our expanded log. Okay, the last one, solve for x. Now we have it in expanded form, so we're going to have to condense it, put it back together. So the 3 goes back up to become the exponent. So this is log of 2 to the 3rd power plus log x. 2 to the 3rd power is 2 times 2 times 2, or 8. So we have log of 8 plus log of x equals log 24. All right, remember with addition, we multiply these two numbers together. So we have log of 8 times x equals log 24. Same log, cross it out. 8x equals 24. Divide both sides by 8. X equals 3. All right, study, good luck, and you can use your notes on your test tomorrow. See you then.